Hello again and welcome to the BAXEDM YouTube channel. And in this video, part 8, I'm going to show how I make the mounting plate for the C-arc. So this top part here. And I'll do some initial assembly of the top part. And I'll start testing the pinch roller mechanism here. Because the capstan mechanism on this side, that has already proven itself in the MK1. But the pinch roller mechanism on this side remains untested. So I'm really curious how this thing will function and how it will work and what kind of wire tensions I can achieve with it. So I'll do some tests of this mechanism. Okay, let's get to it. So here's the stock material that I ordered from Misumi. It's 6061 aluminum. And I ordered it on 6 sides machined. So it's already machined to the correct dimensions. That saves me some effort. I bought this for about 50 euros, which I think is a good price considering the amount of work it will save me to machine something to nice dimensional accuracy that has such a large surface area. You could do this yourself, but if you buy normal plate is always a bit bent, so you need to machine it flat. And you can do that yourself, but you have to use super glue fixturing and a few tricks to do that. And this is just more convenient. It's 50 euros, but I think it's worth it. I hope I won't mess up, because then it's an expensive mistake. But the only thing that I need to do now is machine a few holes and 2 pockets for the motors. So let's go ahead and do that. So the pockets and the holes turned out really nice. The only thing left to do now for me is to tap a lot of these holes. I do not have a tapping head for this machine, so I'll do it manually. And I'll spare you the boring video, so I won't video it. I'll just do it offline and tap all these holes. Okay, the mounting plate is finished. After drilling all the holes, I tapped all the holes and then I deburred them. I also had to drill a few holes on top, these holes here, which are for mounting the brackets that support the feed and exit tubes of the EDM wire. I gave the other side a bit of a shine with some steel wool. Looks really nice. So yeah, looks like a few more parts and then we're ready to start assembly. Okay, so I started the assembly and I finished the assembly of the upper part, and I couldn't resist to start initial tests. Initial tests of this mechanism, because this mechanism has already proven itself, so, but this one is the unknown for me. So it works nicely by opening and closing it. So the first test that I did was I measured the tension force. So I have a gauge to which I can attach some EDM wire, and then I can power the motor and see the amount of torque that it can give and the amount of tension in the wire. And the test failed because at around 12 newtons, maybe 15, it fluctuated a bit. So 12 newtons of tension in the EDM wire, the wheels started to slip. And this is not enough. Ideally, I would like to have a tension force up to somewhere in between 20, 25 and maybe even 30. So the current tension force of 12 newtons is not sufficient. If you have tall workpieces, you prefer, it's better to have the wire tension a bit higher. But this mechanism cannot do that because it will slip. So initially I thought, okay, I'll just tension the spring, put more pre-tension on it, so that I pinch it harder and then it should work. But I was measuring the pinching force, so the force that the radial load that this wheel exerts against this wheel, and that load is already 120 newtons, which is above specification. Because I checked the specification, I double checked it, so the radial load for this axle is allowed to go up to 200 newtons. But that is defined at a distance 10 millimeters from the mounting flange. And we're here at 20 millimeters from the mounting flange. So I'm not allowed to exert forces above 100 newtons on this point, and now I'm at 120 newtons. So I'm already above spec, and the wheel keeps slipping. So this is bad news. This requires a design change. Another problem was that the wire seems to prefer to run off the wheel. Even it is concave. If the wire runs simply like this, then it has a preference to leave the wheel. So this concept is supposed to work, because I know that someone else is using it. So this concave wheel has a slightly larger radius than the convex wheel. So that the convex wheel is always pinching at the heart of the concave wheel. The reason why it's not working in this design is because the wire comes from below, like so. The wire comes from below. Oh no, it's not clipped right. Let's see. So the wire comes from below. Well, actually, what you should do is wrap it a bit around the concave wheel, because if it travels a short distance along the wheel, that travel and the tension in the wire will, and the concave nature of this wheel, will force the wire to self-align. While if you do it like this, the wire does not self-align. Another advantage of wrapping the wire a small distance across the concave wheel is that you get a positive effect from the capstan effect. So the friction in the wire allows you to exert more tension force. So I did some calculations. The friction coefficient between brass and stainless steel is 0.35, And if you make a 180-degree turn, something like this, so you cover half the distance of the wheel, then you get a capstan factor of around 2.5. So with a bit of margin, let's say around 2. So that means that now if I go like this straight up, I have 15 to 12 newtons of tension force, but if I move it around, that more than doubles. So what I need to fix this, in order to fix this, is I need an additional roller, which I did not include in my design. Damn. So something needs to change here. Well, I have a bit of space here left to position a standoff, and then I can mount a wheel here. So it will just fit. I think it will just fit. And then at least I can test that. So I should be able to add this and then test it to see if then I can get enough tension in the wire, and if the wire then does not run off the wheel. If that works okay, then I might leave it like that, or I might change the layout a bit to incorporate a roller next to it or something. But then I have to remake the entire mounting plate. So I'm still thinking, pondering what I should do. But first I will use, or at least I will use now this mounting plate as a testing platform to make sure that if I make something new, instead of just modifying this, then at least I have tested it. Okay, so now I'm gonna go and add the wheel. Okay, I added the roller and it actually turned out quite nice. I'm actually liking this. When the wire in the original design, it went straight down like this, and then it almost touched the bolt heads of these bolts that screw down the lower jaw. But now that the wire moves around like this, it goes around the outside and there is more clearance. That's nice. But of course, that's not the reason why I did it. I needed to increase the tension in the wire without introducing slip, and I needed to reduce the radial load. And this wheel actually does that, so this is really nice. I set the radial load to 80 newtons at this point, which over a distance of about 20 millimeters translates to 160 newtons of radial load on the motor, and the specification is 200, so that's perfect. So when I now close it, this wheel presses against this wheel, and it's within the specification of the motor, so that's really good. But of course, lowering the pinch force will introduce more slip. However, now we have a capstan effect because the wire runs along the concave wheel for about half the diameter. So you get a capstan effect, and it turns out to work really well. So how this works is I still have to make a part here that positions the exit tube to just above where the wire exits here. And then how you thread the wire is you take your EDM wire, like so, you open the wheel, and then you push the wire just a bit inside the tube, not sure if you can see it, and you close the clamp, and then you simply wrap around the wire. That's it. It's like 1 second. So I'm really liking this. I'll turn it on. You can hear And now it's just set at about half the tension that it can do. This is about 15 newtons, but it can do a lot more now. So yeah, it's working really nice. I have updated the model to include the roller on top here. And what I also did was I moved the lower roller a bit more to the left, because it was originally located here. So now when you thread the wire, it runs along the outside here. It used to make a 90-degree turn, but now it's a bit more. It's slightly sloped to the left. But that's okay. It will function just fine. So that's it for this video, part number 8, and see you next time.